Okay, so for this example, it is 2014 sample E, paper 2, and here I'm asked a question about swimming, cycling and running. So here I have Moira produces histograms of the time for 3 events. Here are the 3 histograms without their titles. Okay, so I'm basically being asked, okay, so use the summary statistics in the table to decide which histogram corresponds to each event. Write the answers above the histogram. Okay, so I said the first one is going to be run, cycle, swim. The reason why I've said that is because I've looked here first of all at swim. Okay, so I'm looking basically at my minimum and my maximum. Okay, so my minimum value for swim is 11.350 and my max value is 30.576. So my minimum value has to be 11, and this is the only one that the minimum value falls within that category, and my max up here is in the 30s as well. Right, then I look, okay, so at my cycle, my minimum value has to be 31.566 and my max value has to be 58.847, and this matches here. Okay, so 31 would fall in here, 58 would fall out there, and same with my run, minimum has to be 16.466, my max has to be 37.336, so this falls into this category here. Right, so I'm also asked for the next part, says the mean and the median times for the runs were approximately equal. Estimate this value from the corresponding histogram. Okay, so the mean and the median time for the run are approximately equal. Okay, so I'm looking at my run here. Okay, and we can see that it's not symmetrical, but it isn't far off it. So what I did was I said that the it would be roughly along here. So I said that the mean and median would be equal to about 25 minutes. Then what I had to do is I had to estimate from the relevant histogram the standard deviation of the time for the swim. Okay, right, so what I did here, I wrote it down. So I said the empirical rule says that 95% of the data lies within 2 standard deviations, okay, of the mean, and my mean for the swim is 18.329. Okay, so that's given to me. So from the histogram, 95% of the data lies between 12 minutes and 24 minutes. Okay, so this is my swim. So 95% of data, if you were to put your bell curve on it and if you were to actually go off and do out the empirical rule, this is what you'd find. So what I did was I said 24 minus 12 all over 4, because my intervals are going up in 4, and I got my answer is 3. So my standard deviation is roughly around 3. Okay. Here it says, when calculating the summary statistics, the software failed to find a mode for the data sets. Why do you think this is? Okay, right, so the data is continuous data, so the frequency of any possible value is either 0 or 1. Okay, so that's why it would have failed to get the mode. Down here, I have give a brief summary of the relationships between performance in the different events based on the scatter diagram. Okay, so girls, we can see here they're all positive correlations between each of the different events, but some are more stronger than others. So what I said for the first one is that there's a strong positive correlation between run times and cycle times, and I said there is a positive correlation between the run times and swim times, and that there's a positive correlation between cycle time and swim time. So you just have to comment on the type of correlation. Okay, so you could say the only one that I would say is actually strong is the run time and cycle time. Okay, because it's pretty much a straight line. Over here then, I'm asked, okay, so it says so it says the best fit line for the run time based on swim time is y is equals this. The best fit line for run time based on cycle time is this. Brian did the swim in 17.6 minutes and the cycle in 35.7 minutes. Give your best estimate of Brian's time for the run and justify your answer. So what I did is I subbed in, okay, so based on his swim time his run must be, so I just subbed in the value. Okay, so I was given his swim time and I was also given his cycle time, so I subbed it in into his both of them, swim and cycle, and I got 24.528, and for this, when I did it into his cycle, I got 21.416. So what I did then is I actually just got the average of those two figures. and I got 22.972. So that's what I'd estimate Brian's time for the run, because we're doing it from both different graphs. Here I have then the mean finishing time for the overall event was 88.1 minutes, and the standard deviation was 10.3 minutes, based on the assumption that the distribution of the overall finishing times is approximately normal. Use the empirical rules to complete the following sentences. So 95%, so we know that's 2 standard deviations above and below the mean. Okay, so we're being given my standard deviation and we're given the mean. So I got it between 67.5 and 108.7. Then I'm told, using normal distributions tables, estimate the number of athletes who completed the race in less than 100 minutes. Okay, so I'm getting my z-score, I'm standardizing this. So I have x minus my mean all over my standard deviation. So what I have here is I have 100 minus 88.1 all over my standard deviation, which is 10.3, and I get that's equal to 1.155. Okay, right, so when I get, so I want to find that they did it, complete the race in less than that. Okay, so less than this, 1.155. So I need to find, basically it's going to give me my score in my log table, so 0.8760. So 87.60% of them did it in less than 100 minutes, and my entire survey, if you look back to the very start, was out of 224 athletes. So what I did is I got the percentage of, so I got 87.6% of 224, so I got 196 people. Then for part F, what I have, it brings in probability. Okay, so I'm assuming that athletes are cooperative and truthful. What is probability that the second person she interviews will be the sixth person she approaches? So guys, you can see these questions, probability is kind of linked. So probability that they finish less than 100 is going to be 0.8760. That's what we just found out there. Okay, that they finish more than 100 is going to be 1 take it away, so it's 0.124. So then you're using either your Bernoulli's trial or your probability that we've already looked at. So it's 5 times my probability times 1 minus probability 4, because I'm trying to find that the sixth person she interviews would have done this. So what I get, my answer is to be 0.365. So you might need to recap on your probability again.